Okay, hello, my name is Jordan, and I am going to be doing some math videos. I've been meaning to do them for a very long time, finally getting myself to do it. My goal is to help people, and even if I don't help anyone or no one fucking watches this thing, at least it's good review for myself. Um, I swear a lot, so if you have a problem with that, you know, a door is somewhere. But yeah, I'm fucking excited for this. We're going to start with Algebra 2, but this video isn't necessarily going to dive into the material. It's going to be kind of me ranting a little bit about some fundamental aspects and different ways to think of things. Because I've always been told that that's kind of an important thing. Because if you ever get stuck, then a lot of times it helps to really think very deep into the foundation, I guess you could say, to the very important stuff. And so what do I mean by thinking things in a different way and all that? Well, okay, so we have, let's just say we have shit. I'm going to divide that by fuck, and that's equal to Billy. Oh, poor Billy. I just keep picking on him. Well, he makes it easy, so he has to live with it. So anyway, I'll be like, okay, well, how do you get rid of the denominator? And so I'll be like, oh, well, Jordan, I can just multiply fuck by both sides, and I'll get rid of the denominator. I'll be like, oh, well, you're actually right. So fuck multiplied by shit divided by fuck equals Billy multiplied by fuck. I don't know what he thinks about that, but that's where it goes. So cancel out the fuck, and then we're just left with shit equals Billy multiplied by fuck. And so obviously you're not going to see words in a math book. There's going to be more variables, so like y over x equals z. And so bear with me here on my ranting, because nothing's really connected yet. But we'd do the same thing. So we multiply by y, and then, x. Let's erase that. Let's redo this part. Okay. So we'd have x divided by y equals z. And we'd multiply by y on this side and this side. And that would get rid of that, and so x equals zy. Straightforward enough. But let's think of something a little different. Let's think of this a little differently. How would I write this y here as a fraction? Well, you might remember that it is anything that's over 1. So even if I have n2, that's just n2 over 1. Or 5, that just equals to 5 over 1. Just anything, really. And so let's keep that in mind in relation to this. And let's think of it like that. Okay, so we have the x over y equals z. So we want to multiply by y, right? So, well, this is the same thing as saying y over 1. And with multiplication of fractions, you multiply across, right? Yep. So you have yx over y equals zy over 1. Okay. Now, same thing, you can cancel these out. Alright, so kind of like what we've done. Cancels out. And so then we have y equals zy over 1, which is just the same as y equals zy. Okay. So that's kind of a different way to kind of see that. And trying to allow yourself to kind of see these things or think of them that way, I think will help in the future for this endeavor. Well, let's give another example as to what I mean by thinking of things in a slightly different way. So we're going to ask Billy, why does 2 minus 1 equal 1 over 2. And then it's going to kind of pick something here. But before we completely answer, give Billy a chance here to kind of calm down. He's kind of pissed off at me. He's a grumpy face. He's like, oh, why would you give me this question? Well, you're going to have to live with Billy. Okay, so remember, like, this is another rule. Let's just say you have x to the power of n and then x to the power of m. Well, that's equal to xn minus m. Right, another sort of foundational thing. So let's think of it. Let's think of this. Let's think of 2 to the power of 2. 2 to the power of 3. And we're going to show that this is equal to 1/2 or 2 minus 1. So let's see here. So we're going to play the same thing. 2 minus 3 equals 2 negative 1. But let's think of this a little differently. Let's factor this out. So 2 to the power of 2 is just 2 times 2, right? And let's think of the 3. So 2 times 2 times 2. 2. Swear I'm tired. Anyway, so think about that one. Now remember, we've been crossing things out, right? Well, we have one group of 2 we can cross out. We have another group of 2 we can cross out. And what's left is 1 over 2. And so I kind of like, these are connected, and there's a million different ways to think of different problems and express them. And that's kind of an example as to how you can think of those. I think it's interesting to keep in mind to think of things differently a little bit. Okay, so let's start with some basic kind of rules. And some of these are probably going to be known to you. And if not, don't worry. I mean, heck, I freaked out at this stuff when I was beginning. And there's nothing to feel bad about, just in case. I just like to say that. Okay, so let's say we have a plus b. Well, remember, we can write that as b plus c. It doesn't really matter how we order that. Heck, we can go ab equals. It doesn't really matter too. Be just ba. You can make these any order you want. Let's see. How about a b plus c? What is that equal to if I want to kind of expand that, or yeah, kind of combine them too? So we would do kind of like what we do with what we distribute the a out. The a wants to join in on the fun. So what we have there is a b plus a c, because we're bringing them out and multiplying, because the a is multiplied by what's in the parentheses. Okay, what about a c plus b c? Well, common denominator for one thing, so that means we can just straight up add them. If that wasn't the case, then we would have a little pain in our hands, but let's not get there right now. So because of the common denominator, we can just be like a plus b over c. Fairly straightforward. What about a divided by b times c divided by d? Well, again, multiplication, you multiply across the numerator and denominator, so you have ac plus bd. And Billy here is very happy because AC is important. That's why it's on the top, obviously, and his sun's kind of coming down, and he's not too happy. He's kind of like overheating. Billy is not very excited about the heat, and eventually he just kind of like, he's just like, oh, I'm getting heat stroke, I'm gonna die, I need AC so badly. And, okay. So let's keep going. How about let's do some exponent properties. And as you might know, by exponent I mean something like 2x right there, or like 2. That's kind of what I mean. So let's go over some basic properties on that. So am multiplied by an. Now same base, right? And we can add these two together actually. Because if you think about it, they're well, they have the same base. I mean, if I couldn't do that if it was like y2 multiplied by z2. I couldn't do that, but in this case, because they share the same, we can add them together. So that just means we have a n plus n. Straightforward. Let's make this a little different. What about a m n? What that equal? What is n? He's like, oh, I love this M right here. He's a good person. They're in love. They're a happy couple, and they deserve to be together because you don't turn your back on true love, man. You just don't, man. So the N joins in on the M, and they're happy to be reunited. So we have a multiplied by M. Yeah. And so kind of sort of the same thing as what we were talking about with distributing. What about A, B? I'll just give you a second here. So remember the N, well now the N can have multiple lovers. It's this is, let's just say this is Jill, and this is Miss Daisy, let's just say, and the N's a player, obviously, so he wants to be with both of them. I mean, not my style, of course, but N is just being who N wants to be. Who am I to judge? Anyway, so we're distributing on both sides, so A N and B N. Yeah, straightforward. Let's keep going. Let's make this a little different. What about A over B N? Well, same thing. N's coming on to both of these guys right here. And so A-N is B-N. Pretty straightforward, right? It's not so bad. Not so bad at all. And we went through the A-M plus A-N equals A-M as N. We already did that, and we already did the A as N equals 1 over A-N. No need to go through that. How about A as M equals A minus N? Now, teacher's not going to be happy if he sees negative exponents. Usually, through my experience, they don't like that. They'll be like, oh, well, you can make this simpler, bro. Why would why would you leave it like that? So, what we can remember here is we can flip them. So, A-N, A-M, and remove the negative. So that's a nice little thing to remember. One last one, I guess. What about A, B, N? So, thinking of to over here, you can just flip them, right? Right? Heck, you can distribute them and flip it, but the end result is B over A. And that changes that from a negative to a positive. That is another important rule to kind of keep in mind. Let's see here. What else can we cover? Foil. Not to be mistaken with tinfoil. I'm going to get some. Anyway, so let's just say we have x plus y, and then z plus n. Well, it's distributing, we're going to kind of expand these and kind of combine them and all that fun, jazzy stuff. I forget what FOIL stands for. don't really give a fuck, but I know the process. So we're going to take the x and multiply it by the z. We're going to take the x and multiply it by the n, and the y, z, and y, n. And the result is x z plus xn plus yz plus yn. Yay! There's some tricks to keep in mind, but we're gonna view that later. Okay, so here's a question: why does 4x times 2 equal 4x over 2? Why? Okay, I'll give you a second here. Think about it. Okay, so we can view this part right here as kind of combining some things that we talked about before. 4 over 1 multiplied by x negative 2 over 1. Fine so far. But remember, we can get rid of this negative, right? The negative 2 here. So if we flip it, we have 1, 2. And then, again, multiplication. We can multiply across, so we have 4x over 2. So again, it's nice to think of the background of these things, even if it seems a little pointless potentially. What is well, let's see here. Oh, okay. So what's anything to the power of 0? Well, it's 1. Heck, even if I have 5 zeros, that's 1. Or billion. That's not billion, but that's just going to equal 1. It doesn't really matter at all, as long as the 1. So that's going to always equal 1. Another thing would be, let's say we're crossing something out, right? And apparently this is a mistake people make, and I can see why that would be the case. But we have these two x's here, and we can cross them out. Now, does that equal 0 over y? Nope. Nope, it does not. Your teacher would probably be very, very sad face and tell you that, he believes in you, and, keep that in mind. And the interesting thing is, like, whenever people go into calculus, the thing that always messes them up is algebra and stuff like this. So if you can get a good, solid understanding of, like, algebra stuff, then, you're going to be good. Calculus, aside from that, I didn't find it too hard. Just the algebra was hard, and that was the case for the whole entire class, actually. But I think I'm going to leave it at this, and the actual course material is going to come after this. So thank you for watching. I hope to see you in the next video, and we're going to start off by covering like radicals and all that fun stuff. So if you have any questions, let me know, and thank you for watching.